Hello everybody, welcome back to my YouTube channel. I hope you all are doing well and good. The subject I'm going to be talking about now is Data Science and Visualization, aka DSV, bearing the subject code 21CS644 respectively. So without any delay, let's get into the video. Firstly, we have the contents, that's the introduction, the core components of data science, types of data visualization, introduction to big data, future trends in data science and visualization, and lastly we have the conclusion. So moving on to the introduction. This is an introduction to what is data science. So data science is defined as an interdisciplinary field that involves extracting knowledge and insights from data using scientific methods, algorithms and systems. Data science combines elements of mathematics, statistics, computer science, and domain expertise in order to analyze larger volumes of structured and unstructured data. The goal of data science is to uncover patterns, trends, and relationships within the data in order to make information decisions, solve complex problems, and create predictive models. So, moving on with the next slide. The term data science combines two key elements, that is data and science. Data. So data refers to the raw information that is collected, stored and processed. In today's digital age, enormous amounts of data are generated from various sources such as sensors, social media, transactions and much more. This data can either be structured or unstructured, wherein structured for an example is database and unstructured for an example is text, image and videos. Next we have science. So it is going to refer to the systematic study and investigation of phenomena using scientific methods and principles. Science involves forming a hypothesis, conducting experiments and analyzing data and drawing conclusions based on that particular evidence. So moving on to the next slide. We have the core components of data science. Firstly, it is data collection, that is gathering data from various sources. Next we have data cleaning, that is preparing and cleansing of data for analysis. Next we have data analysis, that is applying statistical methods in order to explore data. Next we have machine learning, that is building predictive models and algorithms. Lastly we have data visualization, that is presenting data in a visual context. Moving on with the next slide. We have types of data visualization. Firstly, it's basic charts, under which we have bar chart, line chart and pie chart. So bar charts are used in order to compare quantities or show the distribution of categorical data. The length of each bar represents the value it represents, making it easy to compare different categories. Next, we have line charts. Line charts are particularly useful for showing trends over time. They connect individual data points with lines, making it easy to visualize how a variable changes over a continuous period of time. Next, we have pie charts. Pie charts are effective for displaying proportions or percentages. Divide a circle into slices with each slice representing a proportion of the whole, making it easy to understand the relative contribution of different categories. Moving on to the next slide. We have advanced visualizations. So scattered plots, they are used to show relationships between two variables. Each data point on the plot is going to represent an observation, with one variable plotted on the x and other on the y axis, helping to identify patterns or correlations. Next is heat maps. Heat maps are used in order to represent data density and variations within a data set. They use color gradients to represent different levels of intensity or density, making it easy to identify areas of high or low activity within the data. Histograms. Histograms are used in order to display the frequency distribution of continuous data and divide the data into intervals or bins and represent the frequency of observation within each bin, with the height of a bar providing insights into the data distribution and spread. Lastly, we have box plots. Also known as box and whisker plots, they are used to summarize the distribution of data. They display the median, quartiles and potential outliers in a data set, providing a concise summary of its variability and the central density as follows. Moving on to the next slide. We have introduction to big data. So, big data itself is going to refer to larger volumes of data, both structured and unstructured, that indentates a business on a day-to-day basis. It's not the amount of data that is important, but what organizations do with the data that matters. Big data can be analyzed for insights that lead to better decisions and strategic business moves. The term big data is often characterized by three V's, that is volume, velocity, variety. Volume itself is going to refer to the sheer amount of data generated every second from various sources such as social media, sensors, machines and transactions. This data can range from terabytes to zettabytes and even beyond. Next we have velocity, that is going to describe the speed at which the data is generated and processed. With the advent of real-time data streams and IoT devices, data is generated at an unprecedented pace, requiring rapid proceedings and analysis to derive meaningful insights. Next we have variety, signifies the diverse type of data being generated, including structured data. Examples are databases, semi-structured databases and unstructured databases. Big data itself is going to encompass the wide variety of data types. Moving on to the next slide. In addition to these three V's, there are often other extensions such as variability, that is inconsistent data flow, veracity, that is uncertainty of data, and value, that is extracting meaningful insights and value from data. Organizations are often going to leverage big data technologies and analytical tools to store, manage, and analyze these massive data sets, aiming to gain actionable insights, improve decision making, and drive innovation respectively. Moving on to the next slide. We have types of big data. Big data can be categorized into three main types based on the source and the structure of data: structured, unstructured, and semi-structured. Structured data. This type of data is highly organized and formatted, making it easy to store, process, and analyze. It typically resides in relational databases and follows a predefined schema. Examples include transaction records, customer information, and financial data. Next, we have unstructured data. Unstructured data is going to lack a specific data model or organization, making it more challenging in order to process and analyze using traditional methods. It involves text documentation, emails, and social media posts, videos, images, sensor data, and weblogs. Despite its complexity, unstructured data is going to hold valuable insights, and advanced analytical techniques like NLP, that is natural language processing, machine learning, and sentimental analysis are used in order to extract the particular meaning from it. Moving on to the next slide, we have semi-structured data. This type of data is somewhere between structured and unstructured data. While it does not adhere to a rigid schema like structured data, it contains some organizational properties that facilitate the analysis. Example is going to include the XML files, the JSON files, that's the JavaScript object notation, and the log files. Semi-structured data often require specialized tools and techniques for processing and analysis. These types of big data often overlap and intersect within the organizations, requiring flexible data magnets and analytical strategies to derive insights efficiently. The diversity of big data types necessitates a multifaceted approach to data processing, storage, and analysis, often involving a combination of relational databases, NoSQL databases, data lakes, and cloud-based platforms. Moving on to the next slide. We have the future trends in data science and visualization. Artificial intelligence and machine learning. Integration with AI and ML is going to enable advanced predictive analysis and automation. AI algorithms can analyze vast amounts of data to identify patterns, trends, and correlations that humans might overlook. Machine learning algorithms include supervised learning, unsupervised learning, reinforced learning, semi-supervised learning, and can also be trained to make predictions and decisions based on historical data. By integrating AI and ML into business processes, organizations can automate repetitive tasks, improve decision making, personalize customer experiences, and optimize the operations respectively. Next, we have AR, that is augmented reality, and VR, that is virtual reality. AR and VR technologies enhance the data visualization experiences by overlaying digital information onto the real world environment or creating immersive virtual environments. In data visualization, AR can superimpose data visualizations onto physical objects or spaces, allowing the user to interact within and explore data in real time. VR can create immersive data environments where users can visualize and manipulate the data in a 3D space, providing a deeper understanding of complex data sets. These technologies are particularly valuable in industries such as architecture, manufacturing, healthcare, and education respectively. Next, We have real-time data visualization. Real-time data visualization allows the organizations to gain immediate insights from live data streams, enabling timely decision making and responses to changing conditions. With the rise of IoT devices, sensors and connected systems, organizations can capture and analyze data in real time in order to monitor the performance, detect anomalies and optimize the processes. Real-time data visualization tools and platforms such as Apache Kafka, Grafka, and Tableau enable users to visualize streaming data feeds, create real-time dashboards, and receive alerts and notifications based on predefined thresholds. This capability is critical in industries such as finance, logistics, cybersecurity, healthcare, where timely insights can lead to competitive advantages and risk mitigations. Finally, we have the conclusion. So, in conclusion, the integration of AI and ML not only empowers organizations with advanced predictive analytics and automation capabilities, but also fundamentally transforms decision-making processes, mimicking human-like cognitive abilities. Augmented and virtual reality technologies further elevate the data visualization experience, providing immersive and interactive environments that closely resemble the human perception, thereby enhancing our capacity to explore and comprehend intricate data sets in a manner akin to human intuition. As the volume, velocity, and variety of data continues to surge, the challenges of managing and visualizing big data are met with advanced methodologies and technologies mirroring human cognition and adaptability. These advancements enable organizations to derive actionable insights from increasingly large and complex data sets, fostering a deeper understanding of the information landscape reminiscent of human cognitive processes. Real-time data visualization in particular serves as a conduit for immediate insights derived from live data streams, empowering organizations to navigate dynamic businesses environments with agility and responsiveness is basically akin to human decision making. I hope you understood all the topics that were dealt in this particular video, right from the introduction to the use cases, the different types of big data, the definitions covered. So I hope you enjoyed this particular video and thank you for watching.